Okay, so now we're going to talk about transformations. So these are the generic rules of transformations that apply to all functions. So first of all, let's talk about the notation on the left is probably something that you're most familiar with seeing, but the way it's written on the right, you might not be as familiar with. I don't know if you've started to look at vectors in physics. If you're in HL Math, you'll start to see vectors in that class with me, but otherwise, this is just the top is an X and the bottom is a Y. It's really not too complicated to think of. It's just turned vertical. So when we're talking about transformations, if we are given any function, let's make this first function f of x, let's make f of x just x squared. That's pretty simple. So if I have the function f of x and if I add some value, so if we have x squared, and let's say our next one we have x squared plus 3. So our c in this case is 3, and this is a shift up 3. So this is a vertical shift up 3. Notice that the sign stays the same, so if it were written in that other notation, this would be 0, 3. If the shift was down, if it was -3, then this would be negative. So notice that the signs stay the same for this. If it says positive, it moves up in a positive direction. If it says negative, it moves down in a negative direction. So from there, we move on to our horizontal translations. So again, this is in the X, and this time, if you take note, there is a positive D here and a negative D here. So the sign actually changes. It does the opposite of what you think it should. And I'll continue to use that phrase opposite for a specific reason that I will touch on again later. But I think of it as these parentheses make an O for opposite. And that will help you remember to think backwards. But let's look at an example. So let's say we have, so now our function would be x minus 3, the quantity of x minus 3 squared. So if we have minus, then look how it goes to the right, which is actually in the positive direction. It does the opposite. If I change it to a plus, it will move to the left, which is technically a negative direction. But when we're talking about horizontals, we always do the opposite. So next would be a vertical stretch. So when you have a vertical stretch, let's change this. Let's make this a 3x squared. So you'll notice that the blue one gets skinnier. And one way to think of this is because it's a vertical stretch, if you imagine that this blue line here, if it's a rubber band, so imagine instead of it being just an open parabola, that's 1/2 of a rubber band. If you continue to stretch it in the vertical direction, if you continue to stretch it up and down, these two sides of the rubber band will get closer together. So let's say instead that this was 300 or 30 and then 300. It begins to get closer and closer together, which seems counterintuitive, but as long as you put the word vertical in front of it, vertical stretch, that's why the two sides are getting closer together. And then on the opposite side, if we make it a fraction, it gets wider. So a horizontal, it gets wider. So this is a horizontal, or sorry, a vertical shrink instead. So if I'm pushing the rubber band closer together, the two sides vertically, the two horizontal sides will actually move further apart. So now moving on, we have a horizontal stretch. So these are the opposite. So when we talk about horizontal stretches, if you have a scale factor, if you're multiplying by a big number, it will do the opposite. So if we have, in this case, let's make it 1/2 x squared. This time, even though we used a smaller number, it got bigger. So it just kind of works again. So you think that if you use a small number for horizontal, it would get smaller, but instead it gets bigger. So it still does the opposite because we're talking about horizontal. So it does the opposite of what you think it should. Continuing on, we have a reflection over the x-axis and a reflection over the y-axis. So if we want to reflect over the x-axis, we put a negative out in front. So now if I put a negative out in front, it flips it over the x-axis. Now in order to see the effects of, I'm actually going to change this to an x cubed because otherwise the x squared won't show it. So this is x cubed. And then let's make this negative x cubed. So if the negative is on the inside, now it reflects over the y-axis. So when it's on the inside, it reflects over the y-axis. Okay, so now all of these things should be a review, but this little section down here, when we talk about combining two or more transformations, when horizontal transformations or two vertical transformations are combined, the order in which they're applied will change the outcome. So this means if I say to do a, if I say to perform a vertical shift up 1 and a vertical compression of 1/2. So first, let's do a vertical shift up 1. So that's a vertical shift up 1. And then a vertical compression by a factor of 1/2. So that's what that transformation looks like. Now, if I do the same two transformations, but in a different order, if I say to transform it with a compression of 1/2, that becomes which are different graphs. I'll zoom in a little bit closer so you can see, but these three things are different graphs. So when you have two of the same transformations, so two vertical transformations or two horizontal transformations, the order that they say to do them in does matter because it makes a different function. However, if you have one horizontal and one vertical transformation, it's the same no matter which way you do it. So even if you did it in a different order, the result would come out to be the same. So there's an important rule to remember with horizontal and vertical transformations. And so this is where we're coming to the opposite. So vertical transformations follow the normal order of operations as applied to arithmetic. So what we mean by order of operations, remember your PEMDAS, which just as a review is multiply or divide from left to right and add or subtract from left to right. It doesn't mean you always multiply first. So when we talk about these vertical transformations, they follow the normal order of operations. So we would do multiplication before we do a adding or subtracting. So meaning we would do a compression, a vertical stretch or shrink before we would do a vertical shift up or down. Horizontal ones work the other way though. So basically it goes the opposite order. So instead, you would do the adding and subtracting first before you do the multiplying and dividing, which I know seems counterintuitive, but if you just remember that the horizontal goes along with the parentheses and the parentheses mean opposite, then you shouldn't have a problem. Okay, so on the back of 2.4, I've given you some practice problems. Instead of going over all of them now, I would like you to try them on your own and see what you understand. That way I can get a feel when you come to class on Thursday, or on Thursday, I can get a feel for what you understand first. So go ahead, do your very best with what you've got. And then on Thursday, if you don't understand something, you can ask questions and I will record it. But I would love to see what you guys can handle on your own first so I can gauge your understanding of transformations. So if you get a chance, just try to look through these problems. I don't expect you to do every single one of them, but just see if you understand what these questions are asking you to do. And otherwise, I will see you on Thursday.